Good morning, good afternoon, good evening. I'm on location today, yes. Today we're going to talk about water, moving water to be exact. We're going to look at the properties of erosion and deposition. I'm here at Chittenango Falls, looking at the power of water. I love coming here. It's beautiful, it's close, and it's got a wonderful sound, the movement of water. Water's pulled down by gravity, and gravity allows the water to do work, move rocks, carry sediment, and when they slow down, it deposits that sediment. So we're going to look today at a few things that are classic water-related erosional and depositional features. The term erosion means to move weathered rock, often confused with weathering. Weathering, again, is the breakdown of rock, and erosion is the transport of that weathered rock. Now, when water slows down, changes velocity, changes volume, that sediment can be deposited. Deposited means left behind. And we're going to look at some examples of that today as we do a little virtual field trip. Chittenango Falls was formed about 12,000 years ago when the last ice age ended. The Laurentide ice sheet melted and retreated, leaving this chasm that the water flows from Cazenovia Lake northward through this area down to Oneida Lake and ends up there. Chittenango Falls is actually the exact same height as Niagara Falls, but it doesn't have the same amount of water flow, so it's not as substantial. We're going to continue to make our way down to the bottom here and keep talking about erosion and deposition. Chittenango Falls goes over several ledges on its way down from the top. You'll notice that there are a bunch of steps that you can see as the water bounces over them. Each one of those steps represents a different rock layer. Each of those rock layers has different hardnesses which make them more resistant or less resistant to weathering by the water movement. Over time, those ledges become more defined and you get a step situation like you see in front of us. As you look around to the side, you see a bunch of cliff edges. Those cliff edges are actually home to a very unique species. It's called the Chittenango ovate amber snail. Yes, a snail. But that snail exists only in one place in the entire world, and it's on those ledges along these cliff sides. As you look down the creek, as Chittenango Creek heads towards the village of Chittenango, you'll see the classic V-shaped valley designed by the vertical erosion of the water cutting down at one location and the sides falling in. Most stream beds and river valleys are V-shaped, which will be different compared to a U-shaped valley you'll see with a glacier later in the week. Now, if you look around, you'll see a lot of larger rocks, and you can understand that it would take a lot more water and a lot more water velocity to move rocks the size of what you see here in the river, in the channel. At some point in time in history, the water volume was significantly higher and the velocity significantly higher to move that water. Here's a great example of the V-shaped valley. Notice the steep sides on both edges going down to a single point in the middle. Water makes vertical erosion at single points, and they create a V-shaped valley. So we've now moved about a half a mile upstream from the falls, about halfway between Chittenango Falls and Cazenovia Lake. My wife and daughter, Courtney, have joined us for the excursion today. I stopped here because this is an area of an outside bend, or as we scientists call, a meander. At one point in time, this stream was straight. That was when it was younger, probably traveling faster. But over time, as erosion took over, the stream began to meander or wander. I'd like you to visualize a water slide. Attached to this assignment is a video of a water slide. Most of you have probably been on a water slide. They're over here having some fun today, trying to skip rocks. It's kind of fun. Imagine being on a water slide. When you're on a water slide, the water moves the fastest to the outside of a turn. So when you go down a stream, inertia pushes you to the outside of a turn. Sorry, when you go down a water slide. Same thing happens here on a stream. When the stream goes around a turn, the fastest water gets pushed to the outside. And there's a relationship between the speed of the water with the amount and volume of sediments that can be carried. Or in other words, the faster the stream, the greater the erosion. So on the outside of a stream, you have erosion. And if you look, you can see how steep the slope is. That's constantly being eaten away by the moving water. But on this side here, where my wife and daughter are finding rocks to throw, you'll notice that it is really shallow. Sediments are deposited on the inside of a stream. This process continues over time, and the bends become more twisty, and the stream becomes more windy as time goes on. So when you're talking about stream erosion and stream velocity, you want to think about a water slide. The fastest water goes to the outside along a curve, and it moves to the middle along a straight just below the surface due to reduced friction. Thus ends our field trip today. I hope you enjoyed it. Please answer the questions that are included, and we'll see you next time.